Okay. So last time we have discussed about the ultrasonic sensor. Okay. So we have seen that this type of sensor is basically used to measure the distance of the target object from the source. Okay. So ultrasonic waves are sound waves that a human being cannot listen to. Okay. And they travel faster as compared to your audible sound. That is what we have seen. And in ultrasonic sensors, we have transmitter as well as receiver. Transmitter sends 40 kilohertz wave which travels through the air and it strikes the obstacle and bounces back to the sensor. Okay, so there is electronics which is in this sensor which is capable of calculating the travel time. And using this travel time, knowing the speed of the sound, the distance between the source and destination can be calculated. So this is the basic principle behind the ultrasonic sensor. So generally it is used for liquid level measurement and they are particularly used to detect the surfaces with any color, any type of surface. It may be transparent, it may be opaque. So for all type of surfaces, this technology is suitable. So that is what is the advantage of this technology. And we have seen that this is the way in which the sensor works. It transmits the waves, ultrasound waves, and they strike the object and they return back to the sensor. Okay, so sensor senses the presence of bounced back waves and it will calculate the time required for traversal of this wave. So here the way in which the time is calculated that is shown. The time of light is observed and from that by using the equation for speed of the sound, the distance between the source and destination is calculated. Okay. Now here you can observe that these type of sensors are non-contact type of sensors and they are used to detect the presence of object, the liquid level, water level, the position of object and the distance of the object from the source. So these are the wide areas of applications. Okay. So if you see day-to-day applications, then water level sensing, drone applications, automotives, and any local drives, they can use this type of sensor. So here, one commercially available ultrasonic sensor, HCSR04, is shown here. Okay, so this is ultrasonic module. It typically consists of transmitter and receiver, and as I told you, piezoelectric sensor is used as transmitter as well as a receiver. So it is capable of generating electric signals at the same time. It is capable of sensing vibrations and converting back into electric signals. So both properties are used as a transmitter as well as the receiver. Okay, the same type of sensor can be used, but two separate sensors are used for transmission and reception. Okay, now this particular commercial device it has a duty cycle of trigger signal of 10 microseconds. Okay, so this is interface to the microcontroller. A microcontroller generally sends the trigger signal to this ultrasonic sensor, and duty cycle of this ultrasonic sensor trigger signal is 10 microseconds. Okay, So when triggered, the ultrasonic sensor generates ultrasonic wave. So after application of trigger only, it is going to generate the ultrasound waves. Okay. So when this trigger is applied, ultrasonic wave is initiated. Then at that time, the time counter is also started. Okay. So as soon as the reflected signal is received, the timer counter is stopped. Okay. And in this way, the time duration of traversal of ultrasound waves is measured with the help of the timer. Okay. So actually the output of this ultrasonic sensor is a high going pulse. Okay. So this is in the form of pulse, and the duration of the pulse is same as that of the time difference between transmitted ultrasonic wave and received echo signal. Okay, so this timing is nothing but the time duration of your high pulse that you are getting out of this ultrasonic module. Okay, so this can be interfaced with microcontroller, and program can be written to calculate the distance. Okay, so distance formula is given by time taken multiplied by speed of sound divided by 2, because this is happening 2 times and hence we have to divide it by 2. So twice the distance will be traveled. So this is what is the basic principle behind the ultrasonic sensor. Okay. So now we are moving to the actuators. Okay, we have already defined what actuators are. Actuators are devices which are converting electrical signal into some mechanical motion, you can say. Okay, so these type of devices are called as actuators. Example of actuator is relay solenoid motors. Okay, so in this chapter we are going to study motors. Two type of motors we'll be studying. One is DC motor and another is stepper motor. So both working principles we are going to study. Already you might be knowing the working principle of DC motors. Do you know how it works? Yes? Yes, can anybody tell me? You can observe some diagram on the screen. From that, can you identify how it works? See, motor is a electromechanical device which uses interaction of magnetic fields. Okay. Due to interaction of magnetic fields, the electrical energy is converted into mechanical energy. So this mechanical energy is in the form of rotation. Okay. So actual device you can observe over here. This device you might have seen or you might have used for some application. So here you can observe the different parts of motor. So here you can see the stator magnets, okay, and rotor coils. So mainly there are two parts, stator and rotor. So rotor is in the form of coil, whereas stator is in the form of permanent magnet. Okay, and between this you can observe there is something called as brush along with commutator. It is used to change the direction of the current through the coil, which causes the motion of the rotor. Okay, continuous motion of the rotor. So this rotor is connected to the shaft. So this is called as a shaft, and you can connect a load to this shaft. Okay, so now this is actual device, and this is the figure or image which shows the working principle of the motor. So in its simplest form, there is a two-pole permanent magnet motor. Here you can observe two poles, one corresponding to N type of N pole of the magnet and S pole of the magnet. Okay, so this permanent magnet produces magnetic field. Okay, and in that magnetic field, there is a coil, and this coil is connected to external DC power supply. External DC power supply through a device which is called as commutator. Okay, so this commutator is connected to this rotor. 1 minute. So here you can observe the commutator is connected to the coil through the brushes. Okay. So here what happens when current flows through the coil, the magnetic field will be produced in this coil, and this have certain orientation. Suppose this side has N type of orientation and this side has S type of orientation. Now what happens due to this flow of current and due to the magnetism, direction of the magnetism,